Okay, quiz is just come. Hopefully all of you already get the quiz. And once you get it, just complete the answer to the questions in the space provided. The quiz will be ended at 1:45, a quarter to 2 o'clock.
อาจารย์ครับ
ครับ
คือผมยังไม่ได้ลงทะเบียนเลยครับเลยไม่มีชื่อในกลุ่ม
ใครอ่ะ
ชัยกิจครับ
ชื่อในกลุ่มหมายถึงกลุ่ม lab เหรอ
ใช่ครับ
กลุ่ม lab ใช่ไหม
ใช่
โอ
ครับ
เค
ผมเพิ่งลงเมื่อกี้เลยทะเบียนเรียน
ครับ But now it is the time to complete the question in the quiz. คนที่ลงเพิ่มเนี่ย เมื่อกี้ใครนะ
ชัยกิจครับ
ชัยกฤษเหรอ ได้ควิสหรือยัง
ยังเลยครับ ผมยังไม่ได้เลย
เหรอ
ผมหาใน assignment quiz 1แล้วผมเข้าไปก็บอกว่า เหมือนผมเพิ่งเข้ามาในกลุ่มมั้งครับอาจารย์
ถ้าคุณเพิ่งเข้ามาเดี๋ยวนี้มันก็ไม่น่าจะได้อ่ะ ชัยกฤษใช่ไหมฮะ
ใช่ครับ
อาจารย์ครับ ข้อสองนี่ตอบกี่ตัวอย่างอะครับ
ข้อ
possible cause อะครับ
2 อะไรก็ได้ตอบเราไปเลย ชัยกฤษเมื่อกี้ผมส่งควิสไปแล้วนะ
ครับผมเห็นแล้วครับ ผมกำลังทำอยู่ครับ ขอบคุณครับ
You only have 2 minutes left. In fact, 1 minute. Because you need to submit it before 1:45.
อาจารย์ครับพอดีว่าหนูทำเสร็จแต่ว่ามันผิดหมดเลยเพราะว่าอาจารย์ฟิกคำไว้อะค่ะหนูเขียนเป็น sentence ยาวๆเลย
It's okay. Because if you write something different from the answer, you will absolutely get 0. So I will correct it manually. Don't worry about it.
Okay thank you
ขอบคุณครับ
It means that some of you have already submit, right? Mostly. Most of you has already completed. สุกฤตนี่อยู่ไหมเนี่ย พิชยา not turn in. วัชรฤทธิ์ is just view. So your status is just view. Just a moment.
ผมกดไปแล้วแต่ว่ามันกดไม่ติดอะครับอาจารย์
Okay. So I hope all of you have already submit, but some have missed the time for the submission. You will not be allowed to submit again. Okay. Today is our first lab. In fact, we are supposed to meet each other in the lab in on the 5th floors of the research building. Unfortunately, this semester we cannot do that. But anyway, I think nowadays the situations, the outbreak situations is getting better. So maybe the faculty, they will review the measures, the health, public health measures, so that at some point the students will be allowed to do some activity in the building. But I'm not sure about the lecture. Lecture, it's still go on like this, but practical session maybe at the end of this semester, if the situation is just like this, then maybe we can start some experimental study. But anyway, we still have to demonstrate you sometime. I think by the third week of February, I will conduct the demonstrations in the labs because from Monday next week, the 1st of February, all the faculty member and our staffs will be allowed to work in the faculty building as well as the research building, so that some demonstrations will be there, but not for the first 2 or 3 labs. So I need to plan. I need to check the instruments again because we haven't used it for a long time. Anyway, by the third week of February, some of your representatives will be invited to join the demonstration, and those representatives has to make a record or probably take a photographs of that demonstration and disseminate the clips or whatever the photographs you have taken to your group member, maybe 4 or 5, 4 or 5 students from the course, or 1 representatives from each groups, because we're going to have 4 groups working together in these labs. But anyway, at the end, we will go to the labs. Okay, but not this time. So this time everything has to go online. Okay, for the first lab, the first labs it's basically we will talk about the aesthetic or physical parameters describing the characteristic of water and wastewater. Today's labs, we will talk about the parameters like turbidity, color, and conductivity. And as the pH is also measured by using the meter, so basically it is the same types of the measurements techniques. That is why I put the pH together with other 3 parameters, which they all use the meter to obtain the value. Okay. Before I proceed to today's lab detail, I want to show you some information about the characteristic of water. When we talk about the water, okay, are you with me on the OneNote page? So I'm now intended to show. Okay, I'm now intend to show you the OneNote page. So our lab's contents today, it's a quiz. We have just finished background. So I will explain you now, and then we will talk about the methodology. So if you get the samples, so how you will measure the turbidity, conductivity, colors, and also the pH. Then the results, raw data, you're supposed to obtain from the lab, so will be distributed. This one, I will distribute this information by 3 o'clock. So 3 o'clock, everyone is supposed to get all the raw data. So raw data will be distributed into 4 groups, group 1, 2, 3, and 4. So I have already give you the information about the groups and the member. You can go to the files and then oh, okay, it's not there. Oh, it's here. Okay, sometimes it doesn't show immediately. Okay, so here you will find your you yourself and a group member associated with you. So the same copy of the lab results will be distributed within a group member. So this is the group 1, 2, or 3, and 4. But for one students who has just enrolled, so what is your name again? ชยุทธอะไร something
ชัยกิจครับ
ชัยกิจ
ชัยกิจครับ
okay ชัยกิจ okay I will send it to you directly, maybe another copies of the data, or maybe I will just add you to some of these 4 groups. Okay, so you have to work together for the in terms of the discussion, and you need to prepare the report. Although the report is an individual report, still you can, however, you can still discuss about the results that you have got it from the lab. So it's supposed to be a raw data. Actually, it is the data that we have taken from the previous year. It's the actual data. I have taken it from the previous results. Then at the end of today's sessions, we will talk about how you can prepare the report. Report is essentially short but contains 2 most important sections, results presentations and also the discussion. These 2 sections are very important, and they are the highlight of the report. So you need to pay attention. I just allow you to cut off the other part from the title page, introductions and so on. So you don't have to write that part. Just starting or begins with the results presentations and follow by the discussion directly. Okay, so these are the activities we are going to do today. Before doing that, before talking about the background, so I like to show you the how can we justify whether the tapped water is safe for the consumptions or not, or for drinking or not. So how we can say, so there must be a kind of a standard describing if the water quality becomes like this, the number showing, the number of each individual showing the characteristic is just like this, then we can say it passed or it does not pass the standard. So this is a kind of how we can you know, how we can describe or we can justify about the quality of water. Okay, now the standard that I'm talking about in case of Thailand, you can find this information from website, a pollution control department, but it's a little bit difficult to find out. Just look at the government office website. So it's just like that. There are too many sentences, too many heading, which is really difficult to find. Where is it? Okay, better start with the Google. Okay, here is the page. In fact, I think the PCD's website you can actually visit in both English and Thai version. I'm not sure. It looks like they changed something. Normally, there is one button showing the language. Manไปไหนแล้วเนี่ย? I'm not sure. Maybe the website is under construction and then they have just removed it from the website. Okay, so if you take a look at here, luckily there is English here somehow. Okay, so for the water, drinking water, tapped water are normally produced and then follow this standard. So if we are interested in the drinking water, so how can we say that water meet the requirements, or is it safe for the consumption? So you have to compare with this standard. Physical characteristic, color, taste, odor, turbidities, and pH. These are all the physical characteristics, and these are the parameters describing aesthetic characteristic to the water. So, for example, color, the method that we used to compare with the platinum cobalt. That is why the color units is also expressed in terms of units of the platinum cobalt. Maximum acceptable values should be 5 unit, but maximum allowable concentration, I mean, sometimes if the production process could not produce water meet maximum acceptable concentration, sometimes, okay, sometimes the colors goes up to goes beyond 5, but it should not be higher than 15. So this is the difference between maximum acceptable concentrations and maximum allowable concentration. Mostly the water quality characteristic for drinking water should actually meet the maximum acceptable concentration, but sometimes this value may temporarily be higher, but anyway, higher than maximum acceptable concentration is okay, but it should not be higher than the maximum allowable concentration. Okay, so it is best if these values are kept below the maximum acceptable concentrations all the time. Okay, again, for the drinking water, tapped water, color should not be higher than 5 according to this standard. Turbidity measured in terms of the Stillwater scale unit should not be larger than 5 as well. pH should be in the neutral range in between 6.5 to 8.5. Some other chemical characteristic describing in terms of the total solids, iron and manganese and so on. Everything has to follow the maximum acceptable concentration. A toxic substance, microbial characteristic, total coliform bacteria, number per 100 ml, milliliter. It's actually equivalent or equal to cubic centimeter. Okay. E. coli. This is another types of the well-known species. We often measure, but E. coli should not be there in the drinking water or water for normal consumption. So you can actually find out this information from Pollution Control Department's websites, and I believe many countries they also have Pollution Control Department, and they mostly have their own standard. So standard may be vary from one country to another, but this is just the water quality standard for the drinking water or the tap water in Thailand. There are some other standards. This one it's the drinking water. The bottled waters, actually the bottled water should contain water with this characteristic. The value measure should not be higher than this value. Okay, these are the standard. So if it's higher than the standard, then we can say that that kind of drinking water, bottled water, do not pass the standard. In fact, it violates the law. If it violates the law, they should not sell the products in the supermarket. Okay, so this is a kind of the drinking water qualities are standard. Anyway, if you visit its website, you will find so many types of the water qualities are standard. Another one is the effluent qualities standard. Effluent means the water discharged from probably the industrial estate should not be higher than the value recommended here. pH should be in the range of 5.5 to 9. Still, it should be in the neutral range, but the range is a little bit wider as compared to the water quality for the drinking water. The temperature should not exceed 40 degrees Celsius. This is just to prevent sometimes some industry they released the cooling water into the natural receiving stream. So this will increase the temperatures in the water, so that this will affect some to some certain degrees to the environment. Color, according to the standard, it should be it should not be greater than 300 ADMI. You see, this is the color. Previously, we were also talking about the color, but the color we just talked about in the previous page. It is measured in terms of the platinum cobalt, but this one is ADMI. So the method of analysis are different. The one which we use to measure the colors in good quality water we measure in terms of the platinum cobalt unit. But for wastewater, we measure in terms of the ADMI. So different method of analysis, different method of from the measurements. Our suspended solids, the 50 milligrams per liter BOD again. So you find this term. BOD should be less than 20 milligrams per liter. So these are the characteristics for the wastewater. Here you will see that for the wastewater, they don't mention about the turbidity. Turbidity it's only mentioned for the analysis of the good quality water or surface water or maybe tapped water. But for wastewater, we are not interested in turbidity because the concentrations of the particles suspended inside is much higher than we can say that is turbid. Okay, so normally we measure in terms of the total suspended solids, TSS. We don't measure in terms of the turbidity. Okay, so some parameters we use to describe the wastewater characteristic. Some parameters we use to describe the tapped water or good quality water. Okay, and some parameters we use to describe the surface water. I'm not sure about other countries, but they have their own method to set up the standard. But for the surface water in Thailand, surface water, they actually classified the surface water resources into 5 types. Type 1 refers to the one with the best quality. Like if you go to the mountain and there's a spring or wells, so you can collect it directly from the well, so from the spring. Spring นี่คืออะไรฮะน้ำผุดใช่ไหมน้ำพุนะฮะokay, so this kind of water resources, it's no chances of the contamination, so it just come from the well directly, and in this area there is no chances of the contamination. This one, the quality it's of the quality of water, it's the best. So you don't have to do anything if you want to take that water for the consumption. The only thing you have to do is just disinfect the pathogen. Other thing, it's not necessary. You need operation, screen, coagulation, flocculation, filtration. These unit operations are not necessary. But type 2 quality, it's not that good. Somehow it get contaminated with some from some wastewater sources. So in this case, we can still use this water for consumption, but we need to treat this water before distributed to each individual household. Type 3 is also good, but not as good as type 1 or type 2. We can use this water for the agriculture purposes, but it is not recommended if you want to swim or play a water sport, because the water may get contaminated with some we don't know, right? Some contaminants or some pollutants. Type 4, the quality it's of course not good, but not really bad. It is not recommended to use this water for the agricultural purposes, but in the industry it may be okay. Number 5 is the worst among the other water resources category. Type 5, it means that water resources, surface water resources, can be used only for the navigation purposes. We cannot use this water for agriculture. We cannot use this water for industry, and we cannot take this water for the to use as the water supply sources. To be more clear, type 5, you will find the surface water type 5 in many areas in Bangkok. Klong San Sap and many other klongs are classified as the type 5. We cannot use that water. We cannot use the water in that canal for any other purposes. We can only travel along the canal with an unpleasant sightseeing, and during traveling, you may have to smell some unpleasant wastewater smell. So this is a kind of how we classify the water. In these 5 types, so how we can say it, like a Chao Phraya River. The water quality in the Chao Phraya River. So that river, it belongs to which type? So you can have a look at here. This is the surface water quality standard. So we classify it into 5 types. You may look at the oxygen, dissolved oxygens. Number 4 is the dissolved oxygens. For the dissolved oxygen, normally water, surface water, should contain the dissolved oxygens greater than 4 milligrams per liter. 4 milligrams per liter. If it is less than 4 milligrams per liter, the aquatic organisms may not feel comfortable to live in that water. Only some species which is very resistant to such very low dissolved oxygen conditions, but mostly the living organisms, aquatic organisms, they prefer to live in the water resources with the DO greater than 4 milligrams per liter. Less than 4 milligrams per liter, it can be classified into class 3. Greater than 4 milligrams per liter, we can classify into class 2, but we still have to look at other parameters, not just this one. Okay, basically, from this table, you will find that we classify that the surface water quality into 5 types, okay, based on the beneficial uses. 4 and 5, it's not good. 1 and 2, it is 1 is the best quality, and 2 it's good quality. 3 it's probably fairly good. Okay, so this is how we classify. So based on this number, we can justify whether these water resources will be okay if we take it and if we use it as the water supply sources. Okay, so these are the parameters, list of the parameters, and the number, maximum allowable number. So you can find out from this website. But anyway, for the surface water, if you really take a look at these parameters, they pay attention on the color. They also pay attention on the pH, but they don't. They're not interested in turbidity. So turbidity mainly used only for describing the good quality water or a tapped water. We don't use turbidity to describe the wastewater or maybe surface water. Surface water sometimes we measure, but just to monitor the quality of water. Okay, but not the regular parameters we have to monitor. So these are the various types of the standard and various types of the contaminants that often found in water. So now I have explained you 3 types of water. The first one is the tapped water. Second one is the wastewater, and this one is the surface water. So 3 types of water. I have already completed the explanations, and this lab you will also get 3 samples to analyze. Okay. Or just a moment, I will switch on the Okay, now just come back to the turbidity, color, and conductivity. These presentations you can download from the files, but anyway, I have modified something so that I will replace that file with the latest version, this one. Okay, first let's talk about color. Color. In fact, we divided into 2 types, true color and apparent color. True color is the color which originated from the organic extract or the vegetable extract. For example, we put the tea leaves in 100 degrees boiled water. So the colors will release from the leaves itself. So this one, it's completely dissolved in water, and the water and colors becomes homogeneous. So this one is generally called a true color. So if we look at the lake or the small ponds where the bottoms contains a large amount of the organic debris. If you take the water from that area or water near the organic debris accumulation, you will find the colors change it to yellowish brown. So this is a kind of a true color. And the second one is the apparent color. So what is the apparent color? So just look at this photographs. This is the point where the river in northeastern part of Thailand meet the Mekong River. Mekong River carry a lot of sediment, a lot of suspended matter. Suspended solids are carried out with this river. So you see the colors turn brown. Okay, This brown is actually caused by the suspended matter. So if you remove this suspended matter, you will see the true colors or its original color. It may be clear like a tapped water. So if we could remove the suspended matter, so apparent color, it's basically the color caused by the suspended solids or suspended matter. But true color originated from the vegetable extract or the organic debris. Why we have to measure the colors? As I told you, this is about the aesthetic problems. So if you realize that this is the tapped water containing some color, you may not feel comfortable to use or to consume that water. So we need to check and somehow we need to measure the colors information will help us to evaluate the chemical uses, because the colors somehow we can apply the process like an absorption process to absorb the colors. So if we know that information, we can provide the sufficient absorbent so that they can absorb the colors from water. So this are the reasons why we have to pay attention on the colors. In order to meet the standard, sometimes we have to remove the colors from water itself. Methods of the determinations, as I mentioned, color we measure by using platinum cobalt unit. The standard platinum cobalt is used. Platinum cobalt, if we added 1 milligrams of the platinum cobalt into 1 liter of distilled water, so it will give the colors like a yellowish colors. And then 1 milligrams per liter of the platinum cobalt, this in fact equivalent to the standard unit of color. So for example, the first one, if we put 1 milligrams per liter, the concentration, so it gives this color. So if we put like a 2 milligrams of the platinum cobalt into 1 liter of color, so we may get something like this, a little bit more brighter, I mean yellow. Okay. If we added more, so the it turns like an amber. Okay, from yellow to amber like this. So this is kind of the meaning of the color unit. So 1 milligrams per liter of platinum cobalt added into water, this equivalent to 1 unit of color. So if we put 1 more milligram, so this will equivalent to 2 units of color. The method that we measure, it's normally called the photometric method. We use the meter to measure. So the details about the measurement, we will talk about it again later. For the sample, as I told you, we have 2 types of color, true color and apparent color. For apparent color, you can take the sample and measure directly because you want to know the apparent color. But if you want to see a true color, how do we measure? You can measure for apparent color. You can measure directly by using turbidimeter. But for a true color, before measuring by using the same equipment, what you really need to do is you need to take the sample, You need to take the samples and then centrifuge. So what is the beneficial use of the centrifuge? Or yes, all the suspended particles will get accumulated here at the bottoms จะเป็นลักษณะของการเหวี่ยงอนุภาคลงไปให้ติดอยู่ก้นขวดนะฮะเหวี่ยงนะครับ so once we centrifuge after the centrifugation is completed we only take the supernatant then we measure the true color. This is how we measure the true color. Measurement equipment are the same, but true color need one more step with respect to the apparent color. That a step is just to centrifuge the sample. Okay, so this is how we measure a color. In terms of the measurements equipment, I will show you it again. The limitation of these equipments is they are capable to measure the color with the maximum value of 550 units. So if you measure and then you get 550, it means that the real value may be 730 or maybe 650, who knows, right? But the limits of these instruments is just 550 units. So in this case, what you really need to do, you have to take the sample, then you have to dilute. So you take the sample, for example, you take like a 50 ml, then you add 50 ml of the distilled water. So the total volume is 100 ml, right? You take these samples and then measures it again. So once you measure, you may get like a 320 milligrams per liter. So if you get this number, it means that the actual value is 320 multiplied by 2 because the dilution factor is 2. Okay. 2:1. 2:1. Okay. Because we put the sample 5 ml and the distilled water another 5 ml. So the dilution factor is 1:2. Sorry, 1:2. Okay. So if you measure the diluted sample and then you get the value 320, then if you want the real value, you have to multiply by 2. So the color is 320. So the volume becomes 60. 320. 640. 640. Okay. So in the afternoon, it's actually not good. Sometimes our brain it's
my brain just
gain.
stopped up then.
Yes. Okay. This is the kind of how we measure the color. And then what is next? In the reservoir, do you know the reservoir? In the reservoir, this is a kind of dammed. So this is the water level. Mostly in the front of the reservoir, the depth is quite deep. I mean, water just in front of the reservoir. So sometimes it's 100 meters depth. And here, sometimes you will find a lot of sediments accumulated including the organic debris. So if you take the water from this side, you will find a lot of color. And if you take the samples from this side, you will find another color. Okay. So if we know this one, if you want to maintain a good quality of water, as you are going to withdraw this water to produce tapped water or drinking water, you have to manage this reservoir to discharge water in the lower part and then take them and then produce waters or use them somehow. Don't keep it for a long time. Okay, so this is a kind of a method of colors inside that reservoir. Other things also, we really need to remove them from the waters itself. Normally when we remove the colors, the best way to remove the colors is we use the activated carbon. According to the drinking water quality standard, the WHO, by the WHO, the color should not exceed 15 units, but in Thailand we allow maximum 5 units. So this is all about the colors. Another parameters is the turbidities. Turbidities is a kind of originated from the suspended solids, but verify particles. The suspended solids normally in water normally interfere with the passage of light, and it may cause light scatter in the sample. So this is the the definitions of the turbidity. What we are going to measure about the turbidity? The turbidity it's something like a okay. So this is the standard. If it turns like this, just look at the far left tube. The color turn a little bit gray. So this seems to be very turbid. The far this one is right and this one is left. Okay, so this one is quite clear. Here you will find this is less turbid. Okay, so what is the major cause of the turbidity? Mostly coming from the sediments. Sometimes it comes from the during the wet seasons. There may be a landslide or mudslide. The floods also bring a lot of sediments. It caused a lot of turbidities in the river. So our turbidities we measure in the stream. Normally we measure in terms of the NTU, nephelometric turbidity units. And why we have to concerns about the turbidities? Because the turbidities is the physical characteristic of the water. So this would affect the aesthetic. The peoples, if they could see water turn turbid, then they may not feel good to consume that water. And the turbidity informations, we also make use of this information to control or to operate the filtration tank. Sometimes we also make use of this information in the pre-chlorination process, because the water, if they are too turbid, we should not apply chlorines, because the chlorine will not be very effective if the water is too turbid. The softeners, water softeners means the process that we reduce the hardness. This one also another process that required the turbidity information. So we will talk about this again in the later chapters and also in the lectures. These are the list of the substance that can increase the turbidities in natural water, suspended solids, colloidal particle, dissolved solids, and even the living organisms like the algae cells. They are very small in terms of size. And if you take the water from the ponds in front of the faculty building, you will find the water turn a little bit green, and that is because of the algae. Okay, mineral origins, organic origins, and gases. This could actually cause the turbidities. It may enhance the turbidities increases in the nature. If you want to measure the turbidities, in fact, there are two ways to measure the turbidities. But right now, we mostly measure by using nephelometric method. In the past, we measured the turbidities by the method called the Jackson-Kandel turbidimeter. In fact, we used 1 milligrams of the silicon dioxide. So put 1 milligrams of silicon dioxide into 1 liter. This will be equivalent to 1 unit of the turbidity. Okay, but this one is the JTU. JTU is the Jackson-Kandel turbidimeter. So I'll explain again what does it means by this method. But anyway, this one, if you could see, so if I expand it, can you find out? Can you see the cap of each bottle? This one seems to be very clear. See, this is only 0.02 NTU. This one is a 20 NTU, and this one is 100 NTU, and the last one is 800 NTU. In our labs, we also have a sample like this, so that you can figure out the water you collected, so how much turbidity can be expected, like that. But we also use this to calibrate the equipment. Okay, so 800. Sometimes during the wet seasons, the turbidity in water, especially the surface water, goes up to 4,000, 5,000 NTU. 3,000 is common during the wet seasons, because I'm talking about the Chao Phraya River, because you will find this value when there was a heavy rain in the northern regions of Thailand, and after that 1 week, all the sediments will reach the central regions of Thailand, Pathum Thani, Nonthaburi, this area. Okay, so at the moment we measure in terms of NTU. So what are the difference between the JTU and NTU? Okay, let's have a look here. You can just visit this website. This website is actually it's actually the Hatch website. Hatch is the company, one of very well-known company. They are in fact manufacture a turbidimeter. So they manufacture turbidimeter. This is a kind of Jackson-Kandel turbidimeter. This is the detector. Okay, it's actually represented the detector, and this is the flames, a candle, light source. And this is the water sample. Water samples is given here. So like source is at the bottommost, and when it gets into the water sample, what will happen? Due to the turbines, some lights get blocked. You see here, some lights get blocked or scatter. It gets blocked or scatter. So if we measure the lights here or here, you will find lights if you measure here at the locations number 1, number 2, and number 3. The lights you measure from 3 locations are will be different, like because some lights are absorbed inside these water sample cells, and some part of lights are scattered somewhere. Okay, so the remaining is just you know some percentage to reach this detector. So basically, a Jackson Candle turbidimeter mostly based on the light penetration, measure the light penetration. But it is different from the nephelometric method, because the nephelometric method, they measure the light scatter. The light, when it gets into the water sample anyway, it will scatter. Okay, so the NTU, they don't measure the light passage, but they actually measure the light scatter. Okay, how do they measure the light scatter? This is the light source. Okay, this is the light source, and then the sample cells is here. The sample cells is here. So like the sample cells is the cells containing water. So we put water in here. If the water turns very turbid, light scatter will be very high. But if it's not too turbid, it's clear, light passage will be very high. Scattering will not be much higher as compared to the turbid water. Okay, anyway, some certain part of light it's reach this part, but some other part of light get scattered. That is why they put the detectors here. They don't put the detector on the other sides of the cells. If they measure the light passage or the light penetrations and measures on the other sides of the cells, so that one is the Jackson Candle turbidity meter, turbidity. But if they measure the light scatter, the detector is 90 degrees with respect to the light source, light directions. Like this is the measurements of the light scatter instead. So the location where they put the detectors are it's different as compared to the JTU. This is the method we normally call the nephelometric method. They actually measure the light scatter, not the light penetration. And this method is widely accepted right now because most of the light get scattered. I mean, in fact, if you put the water sample cells in here, and this method, in terms of the measurements equipment, it will give more reliable results. That is why now the standard method worldwide, they accept this method, nephelometric method, not the light penetration method. So you will see most standard, they report the turbidities in terms of the NTU, not the JTU. Okay. For more information, you can file from Hatch websites. It's American company. I think they sell the various kind of measurements equipment, including the turbidimeter. You can visit their website sometimes. Turbidity is one of the important informations we can use to evaluate the treatment process. Do you still remember we have to produce water with the turbidity less than how much? Less than เท่าไหร่ฮะ NTU. Did you still remember? 5 NTU. It has to be less than 5 NTU for the turbidity data, for the turbidity of the water before distributing to the household. The turbidity has to be less than 5 NTU, and also the color should be less than 5 unit as well. But maximum allowable may be 15 units. That is for the color. Okay. We can make use of this turbidity data. We can use this data to evaluate the performance of the coagulations and floculations. We will do this experiment in the next 2 or 3 weeks, I think. We will do the jar test experiment. The jar test, we will need the turbidity information to evaluate the performance of the alums and ferric chloride, and many other applications. Mostly we use to evaluate the system, water production system. And then the last one is the conductivity. Conductivity, what does it mean by the conductivity? By the definitions, the conductivity is a measurement of the ability to carry the electric current. The higher iron dissolved in the water sample will be the higher ability to carry the electric current. So if we compare the seawater and the fresh water, okay, before we proceed, this is the unit. The conductivity normally measures in terms of the microsiemens per centimeter or micromole per centimeters. This is the SI unit. So I don't want to go into the deep details about this, but at this levels, I think you know the relationship between conductivity and other parameters. This one, it's quite enough if you know this one. So there are close relationship between conductivity and others parameters like salt contents, total dissolved solid chloride in the water. If I asked you to compare the conductivities of seawater and probably the fresh water, you will see something totally different. Seawater has a very high conductivity because seawater contains salt. Salt contains in the sea. Do you know how much? Salt contains in the sea is very high, around 3.5%. 3.5%, it's equivalent to, do you have any idea? How many milligrams per liter? Do you have any idea? 3.5% is equivalent to how many milligrams per liter?
350 ครับ
How can it be 350 มาได้ยังไง
เดาครับ
Guess. 3.5%. So 1% is 1% is actually equivalent to 10,000 milligrams per liter. 10,000 milligrams per liter. Okay, so 3.5% how much is it? 35,000
35,000
milligrams per liter. Why is it equivalent to why 1% is equivalent to 10,000 milligrams per liter? 1 liter is how many grams? 1 liter, how many grams? 1 liter is equivalent to the weight of water, 1,000 grams or 1 kilograms, right? 10 milligrams is equivalent to how many grams? This is milligrams. 10 grams, right? So 10 with respect to 1,000, so it's equal to 1%. So this is how, can I say like 1% is equal to 10,000 milligrams per liter. So that the salts content in the sea, sodium chloride generally find about 3.5%. So that the concentrations is now 35,000 milligrams per liter, very high. As compared to the fresh water, which fresh water salt content is nearly 0. Okay, so this is something difference between the sea water and fresh water. That is why if you measure the conductivity, if you don't have equipment to measure the salinity, if you don't have equipment to measure the chloride, you can measure the conductivity instead. Okay, so these are the relationship among these 4 or 5 parameters. So fresh water, the conductivity is very low. Brackish water is a little bit higher, and the sea water, it's the conductivity reached the highest. And then for more information, you can have a look. This is a very useful link. More detail about the electrical conductivity in water may be described by this figure. So if the water contains more ion, positive and negative charge ion, then they have more ability to carry out the current. Deionized water means the waters with free of ion, the LED light will not be illuminated. Okay, so this is like a the figures describing the how the water can actually carry the current, and here is the information. Pure water, deionized water, the conductivity is around 5.5 microsiemens per centimeters only, but seawater, this value is totally different. It goes up to 50 microsiemens per 50,000 microsiemens per centimeter. So totally different. So if I'm talking about the brackish water, so what would be the conductivity value you would expect it? You may expect it like at 10,000 microsiemens per centimeter, like that. So this is a kind of electrical conductivity. We normally use this parameter. Use these parameters to measure the sea intrusion problem, as I mentioned in the morning. Okay, so this is all about the background for the conductivity. There's one more thing, the pH. pH, what does it really mean by the pH? I don't have anything with this photograph. So pH is minus log hydrogen ion, right? So pH normally linked from 0 to 14. Everybody knows that. But do you think the pH is only linked from 0 to 14? Have you ever seen pH gets minus? Have you ever seen the pH gets minus?
ไม่เคยครับ
Never. But
ใช่
by
ค
the
รับ
definitions, how can you get? Isn't it possible to get a minus by the definitions?
น่าจะเป็นไปได้ครับ
By the definitions, the pH is minus log hydrogen ion. So if the hydrogen concentrations is very high, like the strong acid solution, so you would definitely get the pH minus. But that will not happen in the nature. In the nature, you will mostly find the pH in the range of 0 to 14 only. In the middle, it's a neutral. So the pH in the neutral range, it's a 7, like that. So we just measure the pH because the pH is somehow play the important role in many, many reaction in the water and wastewater treatment. Okay, so background I have already explained it. Now we have a look at the instrument. This is the instruments we use to measure these four parameters. For the turbidity, we used this one. This is the HAC turbidimeter. Turbidimeter. So it looks like this. This is the same model that we used in the labs. You need the sample cell. So we put the water samples in the cells and approximately 25% into these cells. This is a very special cell, so made from a special glass. This glass is actually not gets scratched easily, so they are very strong. We put the water inside up to this mark. The volumes would be around 25 ml. And before the measurement, so we have to whip the sample cells by probably the microfiber cleaner or the tissue paper to remove the fingerprint, because if there's a fingerprint outside, so the value that you have gotten from the analysis will be erased. Okay, this is the equipment. So just put this power button and then wait for some time. Normally you should wait for around 3 to 5 minutes to warm up the lamps. And this is the lid. So once everything is ready, samples and the meters are ready, then we put the sample cells in here. Okay, put the cells in here. Then we closed the lid and then pressed read. Okay, after pressing, wait for some time. The value we show it here. Here, the value shown here it's 1.51 NTU. Okay, this one may be a previous measurement. This is the current measurements, 1.51 NTU. See, this is less than 5 NTU. The drinking water quality standard. It means that based on the turbidity information, we can roughly say this water, in fact, safe for drinking. We can roughly say, but the drinking water we need to base on so many parameters, not just this one. Okay, but this is one of several parameters, but this one is one of the most important parameters. For color, we also use the same. We use different instrument, but made by the same company, HAC. We use this model. They are also they look similar, but they are totally different. The principles, working principle, it's also different. The model that we use is DR850. The color we measure based on the platinum, cobalt. So again, we put the sample in the sample cells. We have the methodologies of cleaning and transferring the sample is also the same as the turbidity. Okay, the samples cells, we put it up to this mark, but the cells is a little bit longer, so you can put it up to 50 ml. And then again, whipped the samples with the microfibers to remove the fingerprints and remove the moisture that may attach on outside the sample cell. Just placed the button. There's a power buttons here. After pressing, in fact, it's not the exit, it's a kind of power button. Exits and starts are the same, I think. Okay, put after locate the sample, then cover this sample with this lid like this. So after put the cover, so it would be something like this. Then again, we place read, and finally the values will come. We show here on the screen. The unit is unit. Okay, colors. The unit is unit. The colors for drinking water should not be greater than 5 units, or maximum allowable should not be greater than 15 units. With respect to the platinum cobalt, the last one, the conductivity meters. The conductivity meters we use in the labs is, in fact, this one. This is the YSI model 33 SRCT meters. This one is actually quite old. The age of this instrument is even older than of you here. I think this one it's older than it's 20 years. It's more than 20 years old. This one, but it is very efficient. Okay, so we put this probe. So it's just like a probe. So we connect the probes to their equipment. This one is the probe sensor. Connect the sensor cables sensors with this instrument. Then we measure. We dip this sensor into the water bottle. Then adjust three-fold knots. So turn the power knots on. Previously, it should be this one may stay on the positions off. So just turn to 1 or 10 or 100. So if you turn it to 1, whatever the values you have gotten from the scale, you can make use it directly. But sometimes for the seawater, the value I have just shown you, the conductivity value, it's sometimes goes up to 50,000 microsiemens per centimeter. So, but here maximum scales is only 500. So seawater, it's very high in terms of the conductivity. In that case, you have to turn this knot. You have to turn this knot into 10 or probably 100. So if you turn this knot to the 10, whatever the values you have got it from the analysis, like as it shows as it shown it in this photo, the conductivity you would read it, you would get it here I think you get 50 micromole or 50 microsiemens per centimeter, 50. But as this not turn to the into 10 times these positions, so the actual value should be 50 into 10. So the value you have got, you will get from the this instrument is 500. So you should get like a 500. You should report a 500 microsiemens per centimeter. So for seawater, you may have to turn this knot to 100 times, like that. So this is the how we measure the turbidity. But before measuring, we need to set up the temperatures, dip the waters in, dip the sensor or the probes into the water, and this needle will show the temperatures of the sample. Then we adjust the temperatures knots to whatever we have rated from the needles. Then make the same. Then read. If you want to measure the temperatures, just turn this knot into these temperatures positions like this. Okay, this one you can also measure the salinity. This instrument has 3 to 4 applications, 3 to 4 parameters you will get from this instruments. The report the units you have to report it in terms of the microsiemens per centimeters or the micromole. The last one is the pH. pH I don't want to talk much in this lab, but next week we need to learn the details, because the pH has very close relationships with the acidities and alkalinities. So we will talk about the pH again. So for pH, the same brand, the equipment made by the Hecht company. This model, we use the Sense Ion 2 to measure the pH. This instrument is capable to measure not just the pH, but they can actually measure the conductivity. They can measure the turbidity, total dissolved solids. They can measure the in terms of the millivolts and so on. It is nothing, just like any other pH meter. Before using, we need to calibrate the pH meter, and then once the calibration is complete, then we can measure the sample. So before measuring, we need to clean, rinse the probes a few times with the distilled water, and then keep it dry, and then measure. Just dip the probes in the samples or in everywhere you want to measure like this, and then wait for some times until the value showed on the screen. So it's quite simple for the pH measurements, but the only thing is pH meter need to be calibrated very often, almost every time before using, and after being used, we need to clean the probes and rinse with the distilled water, and then put it into 0.3 molar KCl or the potassium chloride. So that is all for the methodologies. So now we come to the raw data. In fact, after finishing the methodologies explanations, you will split it into the groups and then do the labs. But as we cannot do it in that way, so you are supposed to do it in your dreams and then get the results. So suppose you have already finished the analysis. So what kind of results you will get? I hope now you all get the assignments, and then each groups we get the raw data. The files was sent along with the assignments now ได้แล้วใช่ไหมฮะ because I set the times for the distributions at 3 o'clock มีใครยังไม่ได้มั้งฮะ ได้หมดแล้วนะฮะ
แลบที่อาจารย์ส่งมาใช่ไหมครับ
ใช่ครับ
โอเคครับที่เป็นหน้าเดียวใช่ไหมครับอาจารย์
มีหน้าเดียว
โอเคครับ
that one is just the raw data like this one. Basically in the real labs you have to do 3 sample tapped water, surface water, and another one is wastewater. You have to measure 3 parameters, 4 parameters actually, the pH and conductivity, turbidity, and then color. So something like this, you will get the results, but we assume that you have already completed, and these are the results you obtained from the analysis. For wastewater sample, a physical characteristic is something like this: pH, turbidity. Wastewater, we don't measure turbidity. Why we don't measure? We are not interested to measure the turbidity in wastewater because wastewater contains a lot of suspended solids. So we rather measure suspended solids than measuring the turbidity. We don't like to measure the turbidities, otherwise the turbidities will be very high. So wastewater, we are not interested to measure the turbidity. Tapped water, surface water, wastewater, we measure the pH. For the conductivity, you can measure all the sample. For turbidity, you can measure the pH. You can measure the surface water. For color, in fact, tapped water, it's not required to measure, but if you measure, you will absolutely get a 0 by a you know, the color limiter. You may get the results of the colors of this surface water. You may get the results of the colors of the wastewater. So basically, you get 3 types of water sample, and then water samples. Okay, so water samples, raw information would be provided. Physical characteristic, pH, color, conductivity, turbidities we don't measure for this lab. For color, as I mentioned, so sometimes it's getting higher than the standards. This one is unit, not milligrams per liter. Okay. So if you measure, if you read it from the instruments, you get 350, but the samples you have diluted 2 times. The actual values you reported should be 350 into 2 because the samples get diluted when measured. So the actual value should be 350 milligrams per liter into 2, so that the actual value is 700 units. This is the final value you will have to report. Conductivity, the temperatures you rated from the instrument, you get 21.5, and then the conductivity from the YSI model, it's going to be a 600 micromole per centimeter. So these are the examples of the wastewater sample. There are some other example, some other results for other samples. You may have a look here. Tapped water, as I mentioned, we don't measure color, okay, because it will not show any value. But for surface water, you may have to report it, the colors. Colors here, they are all apparent color. There is no information linked with the measurements of the the true color, because this information does not mention about the certification. So the sample was not certified. It means that this color, it's the raw data. This raw data, it's the data for the apparent color, not the true color. Okay. So this is just all about the raw data. Then come back to the last sections of today's labs. It's about the labs report. For the labs report, as I mentioned, you don't have to start it from the title page, introductions, objectives, and methods. So this part you can you don't have to include it in the lab reports for this semester. You can start it with the results presentations, discussion, and conclusion, and also provide a special answer. The special answer, what does it mean? If you look at the laboratory instruction manual, each labs at the end of the explanation would contain some question. Okay, this one, the first lab, there are 6 questions, 5 or 6 questions. You may answer the question here. You have to, sometimes it's not, the answers cannot be found from this instruction manual. Sometimes you have to look for the answers from the other sources, like the link that I show you, or from the textbook and so on. So you may have to answer these problems at the end of the report. Then for the results presentations, you should make like this one. This is just the example how you present the results. There are 2 ways to present the results, in the tabulate forms or in a graphical formats. So how many samples you have got? You have, each group gets 3 samples. You should actually mention about the sample. You should mention about the parameter analysis, and then you should mention about the physical characteristic of each sample. The table here, just to give you some idea about how to establish the table and reporting, to report it, the value for the pH, turbidity, conductivity. You can fill up the information here. Dilution factor, are there any dilution factor? You made it. Turbidity, how much you obtain it, how much you get it from the analysis from the meter. Conductivity, did you dilute the sample? If you don't dilute it, just make it 1, so that whatever the values you have got it from the instrument, you can make use of them directly if you don't dilute the sample. So these are probably the examples of results presentations. And then for the discussion, you have to discuss based on the results obtained from the analysis or from the experiments only. We don't discuss some other things which do not link it with our results. Okay, we don't discuss the other thing which do not link it with our results. The point of discussion is like you may compare with the designated standard. So if you are talking about the tapped water, you should compare the turbidity you have got it from the analysis with the turbidity according to the drinking water quality standard like that. You should not compare like the turbidities of the wastewater, the colors of the wastewater, it's higher than the colors of tapped water. Why we cannot do like that? Why it is not recommended to do like that in the discussion? Why you shouldn't compare wastewater with the tapped water? Why? Do you have any idea? The answer is simple. It is not meaningful because the water sample are totally different. They are not the same types of water sample. So if you collect the tapped water from research building, and then if you have another samples of the tapped water collected from the faculty building, in that case may be comparable, but you should not compare surface water with the wastewater, and don't come up with the conclusion like tapped water it's cleaner or the quality it's better than the wastewater. That is the fact, because they are the wastewater. We know that the wastewater it's dirty, it's highly contaminated. Okay, we don't compare in that way. That should not be the point of discussion. You may compare the results with the environmental significance. Not compare. I mean, if you get the results like this, what will happen? For example, if the colors of wastewater you obtained from the analysis is like 500 something unit, but you are allowed to discharge only 5 units. What will happen if you discharge this waste into the natural receiving stream? So this is a kind of propose the idea about the sample. This could be also a good point for the discussion. What will be the health effects if the people would actually consume the tapped water with the results like this? Okay, so this is a kind of a points of discussion, and remember that we don't comment or we don't discuss about the errors, mistake that may arise during the analysis. We should not say like we don't have the experience. We are, we never measure it before, so all the results comes from the analysis has gone errors. We should not comment it in that way, because you are supposed to do it correctly. You are supposed to minimize the mistake and errors by yourself before reporting the value. So this should not be a point of discussion. A conclusion, how to write the conclusion. The conclusion, you should look at the objectives of the reports. Although this semester you don't have to write the objectives, I assume that you have the objectives in your mind. Okay, then if you want to write the conclusion, please refer to the objectives. So suppose the objectives you propose in your mind, like to evaluate the performance of the water treatment by monitoring tapped water quality. So what should be a conclusion? The conclusion should come like tapped water samples that you collected, you have got turbidity value 1.51 NTU. So this definitely passed or meet the drinking water quality standard. It means that our production process is acceptable or reach the point, reach the the good performance like that. So it depends on the objectives. You should not come up with a general conclusion. Conclusion is also the same as the discussion. It should be with respect to your experimental result. Okay. So these are the way how you could write the report, how you could prepare the report. Okay. The results presentation. How did you decide? How will you decide the table? It depends on you. I mean, if you read the academic report, you finally will be able to decide the appropriate table to present the results. Okay. But anyway, please try to design a meaningful, the table with a meaningful presentations. Okay. Okay, so these are the way you would actually write the report. I think to date we have already completed all the contents of the class. According to the methodologies, results, and report writing, do you have any question? มีไหม
ผมงงคำว่า true color นิดหน่อยค่ะอยากให้อธิบายให้ฟังอีกที
True colors, it's actually the colors originated from the organic extract. So it's completely dissolved in water. Even you centrifuge, even you remove the suspended solids, it's still there. So in the pictures, in the my presentations, I gave you an examples of the true color. So suppose you dipped a tea leaves into the hot water. So what color you would expect it after dipping a tea leaves for 30 seconds? You will get something brown. You will get something green if you put a green tea leaves inside. So this color will never be faded out. Okay, so it's still there. That is why we call it a true color. There is no way of removing by applying just the certification method. พอจะนึกภาพออกไหม True color ก็คือสีจริงอะนะฮะสีจริงของน้ำนะครับแต่สีปรากฏก็คือสีที่เรามองเห็นนะฮะแบบ first sight seeing whatever the colors you could observe that is the appearance color but we just measure by using the equipment to get in terms of the number สีปรากฏก็คือสีที่เราเห็นนะฮะคือแม่น้ำเจ้าพระยาเอาอย่างนี้ก็แล้วกันแม่น้ำเจ้าพระยาเนี่ย carry a lot of sediments นะฮะถ้าเราเห็นมันก็จะเป็นสีอะไรเอ่ยสีน้ำตาลใช่ไหมถ้าเราตักมามันก็เป็นสีน้ำตาลขุ่นแต่ถ้าเราเอามาตั้งทิ้งไว้ตะกอนพอมันตกลงมาข้างล่างเป็นยังไงฮะน้ำข้างบนเนี่ยมันไม่เป็นสีน้ำตาลแล้วนะน้ำข้างบนเนี่ยมันก็เป็นสีของมันเองนะฮะไอ้สีของมันเองตัวนี้